Welcome to Miss Roberts' math lesson on variables on both sides of an equation. There's my self-portrait for today. So we're going to go ahead and dive in with an example. Example number 1. So example number 1 is 6x equals 4x minus 10. The goal is to get all of the x's on one side of the equation. I can move them either from the left to the right or the right to the left, either way. The thing I need to use is inverse operations. So the 4x is positive. In order to get it to the other side of the equation, I have to subtract it because it's positive. And so I'm using the subtraction property of equality, or ESPO. The next thing I'm going to have to do is combine like terms. I have 6x, I have negative 4x, which gives me 2x on the left side of the equation. So I've just combined like terms. And then net 4x plus negative 4x is 0, and all I'm left with is negative 10 on that side. So in order to get x all by itself, I'm going to have to divide by 2. If I divide one side of the equation, I have to divide on the other side of the equation. So 2x divided by 2 is x, because 2 over 2 is 1. And negative 10 divided by 2 is negative 5. So negative 5 is my solution. Don't forget, I used the division property of equality. So I used it depot, as we call it. So x equals negative 5 should be my solution. I'm going to run a check. In order to do a check, we do a t-bar chart, as we've done before. So I'm going to put 6x on this side of the t, and then on the right side I'm going to put 4x minus 10. That's my given equation. So now I'm going to replace variables with parentheses and then plug in the number that I found for x, which is negative 5. So I'm going to replace x with negative 5. So I have negative 30 on this side. This side I have 4 times negative 5, which is negative 20, minus 10. So I get negative 20 plus negative 20 is negative 30. So yes, negative 30 equals negative 30, so that one checks out. So there's my first example of when I have variables on both sides of the equation. Now what I'm going to do is give another example that is pretty long. So this one is example number 2. Example number 2 is 5 times 2x plus 4. You can already see I'm going to have to do some distributive property with that one. And that's the left side of the equation. So we still have more. We have 6 plus 2 times 3x plus 12. Again, I'm going to have to use the distributive property. So let's go ahead and do that. That's where I'm going to distribute 5 to each of the terms inside of the parentheses. And so we have 5 times 2x, which is 10x, plus 5 times 4, which is 20, and then plus negative 2x here. Okay, that's the left side. On the right side, I have 6 plus, we're going 2 times 3. Okay, so I have to multiply there, just like I did over here. So I went 5 times 2x, then 5 times 4. Okay, over here I went 2 times 3, and that gave me 6x, plus 2, it's a positive 2, times a positive 12, so I have 24. Okay, so what I used here, let's justify, which means I tell what I did. So it's the distributive property, and I was able to use that here. Okay, now what I'm going to do is I'm actually going to use the commutative property to rearrange these terms. So I'm going to have 10x minus 2x plus 20 on that side. Then I'm going to do 6 plus 24, so I'm going to just bring the 24 up and then add the 6x. So I use the commutative property just to rearrange them so that they're kind of in an order that makes a little more sense. Okay, so this is the commutative property. Okay, so we have 10x minus 2x, so I'm combining like terms to get 8x. So I have 8x plus 20, and then I'm going to have 6 plus 24, which is 30, plus 6x. All right, so there I used combine like terms. And now what we have to do, we have variables on both sides. I want to move the 6x because that way I'm going to be left with a positive x over here. So I'm going to subtract 6x from both sides rather than subtract 8x from both sides, which I could do. It'd give me a negative with the x value. 8x minus 6x is 2x. So I still have 2x plus 20 on that side. On here, this side, I'm only left with 30, so 6x minus 6x is 0x. So I don't actually write the 0x. All right, so what I used was the subtraction property of equality in order to do that, or ESPO as we call it. Okay, so on this side, I'm going to subtract 20, I'm going to subtract 20, so I'm going to use ESPO again here. And so I'm left with 2x, and over here I have 30 minus 20, which is 10. So I used ESPO. Now to solve for x, I'm going to divide by 2, just like our first example. That's interesting. So I have 2 over 2, which is 1. So I'm left with 1x, and that was my goal, is to isolate. So I have 10 divided by 2, which is 5. So that should be our solution. Now in order to check this, I would plug 5 in for x in my given equation. So I'm going to bring this up here as a reminder that for a new term is that an identity is an equation that is always true. So it's like it shows itself back is an identity. Okay, and there may be a case where you have a no solution. So if no value of the variable makes the equation true, that would be a no solution example. So that's it for today's lesson on variables on both sides of the equation. And I'm sure it's going to take just a lot more practice to learn to move, use inverse operations to move all of the variables together on one side of the equation.